One of today's most prominent and advanced physicists, Michio Kaku, has expressed his opinion on recent scientific developments. Kaku, recognized for his outstanding contributions to the field of physics, has recently confirmed that the James Webb Space Telescope, JWST, has discovered 6 massive galaxies that scientists previously thought could not exist. These investigations have the potential to open up new dimensions in our scientific understanding of the universe. It is, therefore, exciting and worth keeping an eye on these developments. Kaku is an outstanding figure in the scientific field. A physicist of American and Japanese heritage, he is considered an expert in both classical experimental physics and quantum mechanics. Unlike some more conservative and skeptical scientists, Kaku does not belong to that group and has been receptive to the amazing results of the JWST mission. We are delighted that this distinguished scientist has decided to break his silence and publicly share what can no longer be denied. The enthusiasm and almost amused tone of the renowned stellar physicist are evident in his comments on the discovery made by the JWST, expressing that this has been the highlight that has piqued his interest. Join us to discover the implications of Michio Kaku's discovery of these 6 massive galaxies. Kaku is a scientist who has always been willing to consider new theories throughout his life. He is aware that Einstein's equations of relativity and Newton's laws are insufficient to capture the full complexity of the universe. Kaku understands that the discoveries of the new telescope have the potential to enrich the scientific field, although many of his colleagues have not been able to adopt this view. It is generating concern and insomnia among proponents and opponents of quantum mechanics. However, this only provokes laughter from Kaku. The JWST has revealed the discovery of 6 massive galaxies dating back to the earliest times of the universe. Each of these galaxies contains more stars than our own Milky Way, despite having formed only 200 to 700 million years after the Big Bang. The team of astronomers who made the discovery has dubbed these exceptional galaxies universe breakers, because their confirmation would revolutionize our entire understanding of the universe. Something doesn't fit here anymore. The Big Bang theory tells us that the cosmos was a hot mess after the initial event. The first solid objects took hundreds of thousands of years to form, and it took hundreds of millions of additional years for the objects to reach sufficient density and produce light. The formation of complex structures such as galaxies was assumed to occur much later. Some of the newly discovered galaxies exceed the Milky Way in size, and their immense luminosity indicates that they were probably forming hundreds of new stars each year, whereas our galaxy forms stars only sporadically. It remains uncertain exactly when the first galaxies formed. Researchers have not been able to determine this so far. The only thing that is clear is that initially there may have only been single stars or groups of stars, which eventually joined together to form larger and larger accretions until dwarf galaxies developed. The small galaxies encountered other galaxies and gradually grew. According to previous theories, highly organized and massive galaxies could not have existed at that time, which raises the question of whether the universe is much older than previously believed or whether complex toroidal galactic arrangements developed much earlier. This circumstance is difficult to explain for conservative science, which still finds problems with this model. Some branches of physics have heavily refused to accept this discovery and question possible errors in the age calculations. Kaku was aware of this and had this to say: "There are many examples of old and false theories that stubbornly persist because of the prestige of some scientists. Many of these theories were only discredited when a crucial experiment revealed their falsity. Therefore, the fundamental work in any science, especially in physics, rests within the experimentalists who keep the theorists honest. In fact, on Earth, we know very little about the true beginnings of the cosmos. The Big Bang theory was established in 1927 based on observations of the expansion of the universe. These data led to the conclusion that the cosmos originated from a single point and has been expanding ever since. At the time, it was difficult for people and scientists to conceive of a universe with a beginning and an end. The idea of a universe that had always existed and was infinite in time and space was beyond people's imagination, and even today, scientists still face difficulties in understanding it. However, it is important to consider these probabilities once again. These new demonstrations do not fit at all with what researchers have based for decades on the Big Bang theory. However, science has shown time and time again that reevaluation and openness to new ideas are an integral part of the scientific process, as is the confirmation of certain theories and observations. When Einstein was a child, it was believed that the stars and planets were firmly fixed in the universe and that these particular structures occupied a defined space. However, we now know that everything in the cosmos is in motion. Planets orbit stars, stars move within their galaxies at hundreds of kilometers per second, and entire galaxies move rapidly through the cosmos, the fate of which we cannot yet predict. Today, scientists are challenged to accept uncomfortable truths and understand that theories are only guesses and not absolute truths until they are rigorously tested or confirmed by accurate observations. The idea of the Big Bang arose from the realization that galaxies are moving away from each other, and this distance is proportional to the distance from Earth. This observation, known as Hubble's law, suggested that the universe was expanding. For a long time, elements such as cosmic background radiation and the redshift of light from distant galaxies and other cosmological structures seemed to support this theory. However, it is important to remember that in the past, people who believed that the Earth was flat and that the Sun revolved around us also had this kind of evidence for their assumptions until coincidence or technological improvements came along that provided a clearer and more accurate picture. Right now, we are witnessing a similar situation. Scientists expected the new JWST to confirm the assumptions related to the Big Bang, but instead, they have come across these 6 galaxies that seem to be impossible. This reminds us that science is constantly evolving and that scientists must be open to new discoveries and rethink existing theories based on the available evidence. Researchers use redshift as a tool to determine certain quantities in the study of the cosmos. Redshift, also known as the Doppler effect, refers to the change in the color of light as the light source and the observer move relative to each other. To understand this, imagine standing still and seeing a car coming towards you. As the car moves towards you, you hear the sound of the engine getting louder. However, once the car passes you or moves away from you, the sound of the engine changes. This is because the sound of the engine varies as the car moves. The same is true of light. When a light source, such as a distant star, moves towards us, the light we perceive shifts towards bluer hues. On the other hand, when the light source moves away from us, the light shifts towards redder hues. This phenomenon is called redshift. Physicists have converted redshift values into velocities and distances for measurement in the study of the cosmos. However, it is important to note that small errors in these measurements could have significant effects. The measurement techniques previously used are currently under review, and it is interesting to see what results scientists will arrive at. As for the latest demonstrations related to our cosmos, it is necessary to consider whether they are really based on redshift errors or whether some scientists are simply denying the facts. This is a question that requires rigorous analysis and careful review of the data and methodologies used in the research. As scientific inquiry progresses, the revelations brought about by instruments like the James Webb Space Telescope often challenge our preconceived notions about the universe. The recent discovery of 6 massive galaxies dating back to the early epochs of the cosmos is one such example. These galaxies, which defy conventional theories of galaxy formation, raise profound questions about the timeline and mechanisms involved in the evolution of cosmic structures. The James Webb Space Telescope, successor to the Hubble Space Telescope, is equipped with advanced technologies that enable it to peer deeper into space and observe with unprecedented clarity. Its ability to detect light from the distant reaches of the universe provides astronomers with a window into the past, allowing them to study galaxies that formed billions of years ago. The discovery of these ancient and colossal galaxies challenges existing models, which predict that such large structures should have formed much later in the universe's history. The implications of these findings extend beyond astronomy and into the realm of fundamental physics. They force scientists to reconsider established theories about the early universe, including the Big Bang theory, which posits that the universe began from a singular point and has been expanding ever since. While observational evidence, such as the cosmic microwave background radiation and the redshift of distant galaxies, initially supported this theory, the discovery of galaxies that appear too mature for their age complicates this narrative. Michio Kaku, a prominent physicist known for his work in theoretical physics and popular science, has weighed in on these developments. Kaku, who is known for his ability to bridge complex scientific concepts with accessible explanations, recognizes the transformative potential of the JWST discoveries. Unlike some of his more skeptical peers, Kaku embraces the notion that new observations should prompt revisions in scientific thinking. He has emphasized the importance of experimental evidence in shaping our understanding of the universe, underscoring that theories must continually evolve to accommodate new data. The debate sparked by these discoveries reflects the dynamic nature of scientific inquiry. On one hand, there are proponents who argue that the discovery of early massive galaxies suggests a longer timeline for galactic evolution than previously thought. This viewpoint challenges the traditional understanding that galaxies grew gradually over billions of years through mergers and accretion of smaller objects. On the other hand, skeptics caution against prematurely discarding established models based on limited observational data. They advocate for a cautious approach, suggesting that anomalies in data interpretation or measurement errors could potentially explain the unexpected findings. Kaku's stance on this issue resonates with the broader scientific community's ongoing efforts to reconcile new observations with existing theories. He points out that the history of science is replete with instances where long-held beliefs were overturned by crucial experiments. As technology advances and our ability to probe the universe deepens, it is likely that more unexpected discoveries will challenge our current understanding. The discovery of the universe breakers, as these galaxies have been termed, serves as a reminder that our knowledge of the cosmos is far from complete. The nickname itself reflects the profound implications of these findings, as they have the potential to upend decades of cosmological research. If these galaxies are indeed as ancient and massive as they appear, their existence may necessitate a fundamental reevaluation of how galaxies form and evolve. This reevaluation could lead to the development of new models that better account for the complexities observed in the universe. As the JWST continues its mission, astronomers will likely uncover more surprises that challenge existing paradigms. The telescope's ability to capture detailed images and spectra from distant galaxies opens up new avenues for research, enabling scientists to explore questions that were previously beyond our reach. With each new discovery, our understanding of the universe grows richer and more nuanced, driving the progress of science forward. The recent revelations by the James Webb Space Telescope underscore the importance of maintaining an open mind in the face of new evidence. As Michio Kaku suggests, science thrives on the willingness to question established theories and embrace the unknown. The journey of discovery is ongoing, and the universe continues to reveal its mysteries to those who dare to explore its depths. In summary, the James Webb Space Telescope has unveiled a series of discoveries that challenge our understanding of galaxy formation and the timeline of the universe. These findings, supported by the insights of physicist Michio Kaku, highlight the need for a continuous re-examination of established theories in light of new evidence. As scientists grapple with these revelations, the importance of experimental validation and open-mindedness remains at the forefront of scientific inquiry.